All right, hello and welcome to another Python video here. Our topic today is relational databases in Python. This is a really critical topic. Why is it important? Because the relational database in corporations is where most of the sales, customer, and other important information about a company's transactions is stored. And if you're going to be doing like business analytics to try to predict what product a customer might want to buy next or something like that, it's going to be on that sales history in the relational database. So I would say the relational database is usually your most important source of data for doing business analytics. And in fact, it's so important we have a class devoted to it in 602. So most of you people tend to either take 602 in parallel with 609 or after 609. So uh, that is a course that just delves very into a lot of detail about relational database design, why the design is there, and things like that. Um, so what I'll do in this course, I don't want to assume you've had 602 because there's a lot of detail to it. I will keep the database design to a minimum, and really I'm going to focus on how to include your database design and work with the database from within Python. A good thing to realize is later when you take 602 or if you're taking it now, much of what you learn about 602 in the SQL language can be done from Python, right? So I'm only going to do a little bit of relational database in here. Um, and in 602, you do more relational database, but the key is the way you put your manipulation of the relational database in 602 can be done through Python. So you learn things that I won't be able to cover today, but when you learn them, realize there probably is a way to work back and do that from Python if you want to do it that way. So just to kind of a brief overview of what a relational database is. A relational database is mostly focused on tables. And tables look a little like an Excel spreadsheet where the rows are records of data. Say one row might be a customer, and the columns are fields of data like the customer's first name, customer phone number, customer ID, things like that. So we have a two-dimensional object. It looks like an Excel spreadsheet, but you can do a lot more. You can do some sophisticated things with it. You generally have a primary key that identifies a row. And we have the concept of a foreign key. If one table has to reference another table, we use the key of the other table to reference it. And when we do that, we say we're using a foreign key. So the keys become pointers between tables. That only has to be semi-clear for this class. You don't really have to have that down. When you get to 602, they're gonna make you do that in a lot of detail and really pay attention because 602 is important because you're going to have to get your data in a relational database, and that database design will be a lot more complicated than we'll do in this exam. All right, so let's oh yeah. So the next point I want to make is the key to manipulating data in a relational database, or the way you do it, is through a language called SQL or SQL. Okay, so Python itself doesn't sort of really directly manipulate a relational database. Relational databases have this standard data manipulation language built into them. And it's fairly standard. There's a lot of brands of relational databases, and they all have SQL in them. And if sometimes it varies in the details, it's a semi-standardized language, not perfectly standardized. So what we have to do in Python is we write that SQL, store it to a string variable, and send it off to the relational database and let the relational database execute that. So Python doesn't know SQL and relational databases don't know Python. So we write our Python code as the overall code of our app, And when we need to get data or insert data or manipulate that database, we write up the SQL code, put it in a string variable, and then we call our API to the relational database and send it to them. Okay, so we are going to do that in this class. There's a relational database called SQLite, and it is, or SQLite, sometimes it's called, and it comes with the standard installation of Python. So if you download a version of Python or whatever and you want to use it, you'll kind of always have it available. It is not the same relational databases that many companies will use. So a company might use a different database product, not the built-in SQLite product. And generally, that just means there'll be a different way to connect to it. Like your IT department will have to tell you the unique way your company connects to their relational database. But once connected, you'll be doing the same thing we're doing here, putting the SQL language into a string variable, sending that string variable off to the database to be executed. So I think that's kind of the background information. So let me scroll down and show you the code. Connect to drive file. Okay, so right, the relational database is stored in a file, and in our case, it'll be stored on our Google Drive, and this is going to make the connection to that. And I've already run it once, so it's already mounted. But you saw that before in the last example. Um, and then we're going to import SQLite 3. So remember, the import means we're importing a module. Uh, it's not generally a part of Python that's not activated, not accessible to you. Um, it is it is in, excuse me, it's installed when you install Python, but it's not available to your code until you do the import. DB path here, DB path, just a string variable, right? So we're still just Python string variable, and in that variable is the path to the database file. And so I just did this. I used my hotel, and so I'm going to make a hotel database, and that's the file I'm going to use. But right now it's just a string variable, so I'll put that in there. Remember where it says my drive, my hotel, that means this file is going to go in the root of my Google Drive. Uh, and then I connect to it. So I connect to it using an SQLite 3 object in the connect method, and I send it the path of what I want to connect it to. And that gives me a connection object. So I've created a connection object. Line 11 is the line that will be, could be completely different in your corporate environment, right? Line 11 will be completely different if we're using Oracle on the cloud or something like that. So this connection stuff will be completely different. And you really have to just talk to your IT department and see. Within the connection object, I create a cursor object with the cursor method, and I get cursor. That's really kind of a pointer to where we are in the database. You don't really have to know the details of it, but that's more or less what it is. Okay. And I'm going to start by creating a table. Okay. Um, let me, the way I want to do this demo, I think I might have a leftover table there. I'm going to scroll down and execute my delete table here. I'm going to explain this later, but I want to make sure I do not have a table my first time I run this, just to show you. All right. Sorry for that little aside. So I made my Ba-da-bam. 11 and 12. I made the objects. These are just connections to the file, to the database. Now, here's what I told you about the SQL language being embedded in a string variable. So I use the variable my query equals and the three in an extended string variable with the three quotes. So using the three quotes, you can make any kind of string variable you want. The three quotes are there because the SQL language will likely be a long quote, right? Because it has a lot into it. And by can none of this indentation within the string makes a difference. What we do is we do the indentation within this extended string in a way that makes the SQL code readable, because why our code is just going to get complicated, right? We're putting complicated SQL inside potentially complicated Python, and it's very unreadable. So the format you see here is use the extended string and then use indentation within the extended string to make the SQL readable. None of that really matters. Just the text of that matters to the database itself. And then within that, we made that cursor object up here. The cursor object method execute takes the string, my query, sends it off to the database, and the database executes it. So this whole thing happens on line 20. So right in line 21, we just defined a string that has SQL in it. Line 28 executes that SQL. And the SQL. So again, in this class, I'm not going to tell you everything about SQL. You will get everything about SQL in the other class, but I'll just give you little bits of it. So create table is for making a table in your relational database. If not exists, um, if not exists means if, and the table I'm making, table name is guest. Okay. So it creates a table guest if a table guest does not exist. If a table does exist, then it just skips this step. Basically, it just skips over this if it does exist. And so if not exists, I put that in there to make the code robust, right? So if there's a table, I'll create it. I mean, if there's a table, I won't create it. I'll just use the one that's there. If there is not a table, then I'll make one. So this will work in a database that has a table or not. So some of the code I've tried to make that way, so it'll work if the thing exists or does not, depending on how many times I've run the code. So I create the table. 28 actually executes the creation. And then now it's a blank table with three columns. It has an ID, a first name, and a last name. So these are the columns in the table. You can have any number of columns. You can have different uh, data types. I've got an integer and a text. Not null means it's required. Again, this is all SQL. You don't have to learn a lot of it in this class, but you will later. Realize when you learn more sophisticated SQL, it will still fit in your Python code as a string can be sent to the database. All right. And then my query, I make a new my query. So I'm just reusing the same variable name. It's a string, but now I'm inserting into guest. So insert into guest means put data into a table named guest, which is one I created up here. And I'm putting in first name in the, and I'm using, these are the columns. So what data am I using? I'm using first name and last name. And see this values thing? So this query means put a new row of data into guest. In the fields, first name and last name, substitute two kind of mystery values. That's what the question marks mean. So that's what this means. And then my second variable here is a tuple. My data is a tuple with two strings in it, the actual data. So we kind of, as a standard, this is not required. We could have built something that had this built in, but as a standard, we put question marks where the data should be substituted into the insert. And these basically happen in order. Like first name goes with the first question mark, last name goes with the question mark, and those line up with the two variables in the tuple. First, Charlie will go to first name. The standard is done so that we can have different types of information. So sometimes a data type will conflict with with the SQL syntax. Like we have commas and things in our data, and then the syntax is looking for data. So it helps protect that. So it's kind of a standard way to do it. And then line 37, cursor execute my query data. See, so the execute method, the first string, the first argument in the execute method is a string with the SQL in it. The second object, as you might have guessed at this point, is optional. and it has data to be substituted into the question marks. So that's why line 37 and line 28 are different. My data is optional. In line 28, there were no question marks, no data. So now I've inserted this, and so I've inserted Charlie Smith is now in my database. Now, say I have a list of tuples to insert, right? So my query, I guess I've repeated the line of code here, but my query does not change, right? So my query is exactly the same as it was before. Now I have a list of tuples. I want to insert 3 new customers or guests. These are guests, sorry, guests into my guest database. So now I have a list of tuples instead of one tuple. And then I use a for loop. So for I in my data. So I will become one of these tuples. Cursor execute my query. I becomes the same as we did here. So another advantage of using the question marks, right? The query doesn't change, but I may be doing a big upload of data with lots of data. So I'm putting 3 guests in. So the guests are in my data. I loop through my data and um, execute that. Line 52, commit. So, and again, I won't really go into the technical reason for this, but commit means the data that I put in is now, I'm done entering data and it's permanent. Okay, so it just sort of, it basically tells the database I'm finished. The reason for it has to do with the relational database is a multi-user system. So if I say a customer bought a new product and a manager writes a report, that data won't be read for the manager's report until I hit commit, because I'm looking to see if done some sort of error. And so if I don't commit, that data won't go in the database. But again, remember, that's telling the database we finished with our data entry. I put one here, um, but it's for technical reasons, so we don't really have to cover too much in here. All right, so create a table, insert rows of data into the table. Let's slide down to line 54. Line 54 is when we do a query. So select asterisk from guest. That means select all rows. That just means all rows. So instead of that asterisk, that's where you put fancy query material, like select guests that bought, that stayed more than 5 days and ordered dinner more than 3 times or something, right? So really fancy queries to get data out can be put in place of that asterisk, and you will learn those queries in the other class, and you can insert them in here, but we won't really go too far into that in this class. So select all rows from table guest and print them, and then we'll make a new table, create a table of not guest order. This is an order made by a guest. You'll see guest num is an integer in the guest order table. That is the number of the guests that made the order. So we know who made this order. So the ID is the ID of the order. Guest num is the ID of the guest in order. That's called a foreign key in relational database terms. We're not going to kill that in this class. Um, Execute it, create the table, and we'll put in a stake order here, and we'll print that out. And so the output here was this print cursor fetch all. That printed out this first line of output because we had the 4 guests. And the second print cursor fetch all printed out the stake order. Now I want to show you something interesting. I've executed this line of code, right? If I execute this cell of code again, what's going to happen, right? It won't recreate the guest table because it already exists, but it will continue to insert data. So if I execute this code again, we'll actually double all the data in the table. So I'll just execute this just to show you that. And you'll see when I execute it again, I will now have 2 copies of the data. If I execute again, so right, this is really how we want to write the code, but we're getting different copies of the data. If I wanted to start over, and again, we wouldn't normally insert the same person twice. You can see how the ID of the second copy of Mick Jagger here is an 8. That means the computer is considering the second entry as separate persons. So this Mick Jagger and this Mick Jagger to our database design. Again, simplified database design. Um, Look at this set of code. This set of code deletes a table, right? So I'm connecting to my hotel database, connection cursor, and here's the SQL for deleting a table. Drop table if exists, guest, drop table if exists. So if the table guest is there, delete the table, commit the table, close the connection, and execute it. And then how do we know what happened? We go back up to this set of code, right? Now, when we execute this set of code, there won't be duplicates, so there won't be tables. They'll be blank. It'll create the table for the first time. It'll execute that. And when we print out the contents of the table, it'll just be in there once. So again, these two cells are for you to kind of see. You can delete all the tables, start over, create a table, add data, things like that. Normally, we'd look up and see if that person is in our database. Again, I didn't want to have all the SQL for that. Let's keep going down. So now I'm kind of building on this hotel management system in our hotel DB. Um, and so you can see from here, now in this section of code, I'm just expanding on putting some functions in to do some things to my DB. So think of this as you can compare this to what we did with the object class to try to make a little hotel management system. This is a little bit more professional though, because we're not storing the data to a variable. See, the problem with variables is, right, you probably know the variables are deleted every time your session is over, right? They're not stored anywhere. It's not due data. So if we if we don't store them somewhere that's persistent, we won't have that data. So obviously our sales data, we want last year's and 10 years ago data. We want all the data there. So that's why we moved to a database. And I've made some functions such as add guest and see what it does. It prompts the user with the input, the input. It makes a query with the question marks to insert those values, and then sets the input from my user, first name and last name, becomes the tuple to the query, right? So cursor execute. This allows us to put a new record in the database based on what our user typed in. And again, I'm kind of simplifying. I'm not really doing a lot of error checking and stuff here, but okay. Printing guests, right? Um, This time I'm using a different, I'm using fetch all slightly differently here, right? So I say rows equals cursor fetch all rather than just printing. Remember last time I just printed out the fetch all, just kind of dumps all the stuff to the screen. But if I do rows equals cursor fetch all, I can do for row in rows, and that lets me format each row, right? So if I do cursor fetch all is a bunch of data, not formatted, setting it equal to rows and doing for rows and rows lets me manipulate it one row at a time, and I can format what one row of data looks like. So much easier to read than the previous example. I can add an order, print order the same way. Print orders by guest. This is sort of a simple Python way. What I've done is I've embedded two queries. I've selected all my people, and then I've printed out all their orders. And what I've done is I've selected the ID guest number description and price from the guest order table where, so here's a new piece of SQL for you, where the guest number equals the ID, right? So I for each, I'm basically kind of the same. I've got two for loops with the fetch alls. And for order rows. See, so keep my cursor and row variables separate, right? So I got my cursor and my rows. But here I've made a new cursor I made the order cursor. So I have two cursors in this database, one pointing at where I am in the guest table and one where I am in the orders table. For each guest that I pull out, I go to the orders table and do select all the orders where the guest number is the same as the ID I just pulled out of the table. And then I loop, if they have a bunch of orders, I loop through those and print those. So that's a little more complicated. Um, there are actually some, rather than what I did, I'm kind of explaining Python and trying to give you some more examples of SQL. And what I do is I'm taking the guest or each guest in Python, I'm using a Python loop to look for the orders for that guest. There are ways to actually do all of this in SQL. Like so instead of this, I could make a really sophisticated SQL statement that says, give me all the guest orders for guests who have orders. That can actually all be coded in the SQL. So in this example, I kept my SQL simple, did the data manipulation in Python so it was visible to you. um, After you take 602, I would suggest it's probably better to make all of this logic of finding the guest orders in your SQL statement, and then you would just have one type of printout, most likely. And there's trade-offs. Sometimes you do it one way versus the other way, but this is assuming high SQL, I mean, low SQL knowledge and high Python knowledge is the way I did this to demonstrate some concepts. Realize when you become a hotshot at SQL, it all really could have been done in the SQL portion, and often that would be a better choice. And then I made this. This is a menu. So the user can of my hotel management system can select things off the menu. We select things off the menu and work on that. So you can execute that and try it out. That is database management from Python. Uh, the SQL I've done is kind of simplified, but that gives you an idea of how we make that connection. And you're going to be doing this all the time as a data analyst because often you're going to be analyzing customer data. Depending on how an organization is set up, some corporations, maybe the IT department will pull that data out of the SQL database and put it somewhere else for the business analytics analyst so they can kind of manipulate that data again and not really send queries to the main database. So that's just kind of an organizational security issues become involved there. Well, great. Thank you very much. And I hope you have fun with relational database.